So since I couldn't find a YouTube video explaining what an earth flow is, I decided I was just gonna make my own little video. So here's a title slide, and I put the idealized model in the top left corner, and then kind of what it might look like out in nature in the bottom left corner. And I'll get into more of why it looks like that. But there's just a basic overview of what it looks like. So here's just the basics, and there's a lot on the slide, so I'll just take you through kind of the basics, starting with what is a flow. So it's when a mass of material flows together as if it's a liquid. So it's when your solids are kind of flow like they're liquids, and it's often they act like they're liquids because they are partially saturated by liquids. So like think about rainwater, that often influences them. They're plastic in nature, which means they're like brittle. They can break up, and I put in the parentheses retain shape as it flows, but it's not really quite correct about being plastic in nature. It just means it can be broken down, and often in your flows, you get stuff that's reworked, so it doesn't quite retain its shape. It retains its shape more in a slide than a flow. Of course, it's driven by gravity, as every other type of landslide is, and it's often initiated by some quick event like sudden rainfall or volcanic activity in the case of a pyroclastic flow, or an earthquake, which is going to loosen up the soil. So then the Earth classification doesn't just describe what kind of material flows. So of course, Earth, it refers to like the soil, and maybe like some smaller sediment is going to be moved. And larger grain material can be moved, but not in the same way that it is by debris flows. And it's not necessarily fast either. It moves more closely to a creep kind of, but it's not really slow. It's all relative. So it's not like a debris flow or rock flow. That doesn't mean that it's not a little fast. It's kind of relative. And then it's often starts moving through liquefaction. So I kind of said that about flows, but this specifically moves through liquefaction and then saturation of water and then into solifluction. So then, as I showed in the other slide, kind of the features of earth flows. So general soil and clay materials associated with the flow is reworked. That's very important, and it flows in an hourglass shape. And then this reworked material eventually stops from the flow of gravity, and it keeps together in a toe. And it kind of stops earlier than the faster debris flow, and it's a lot more uniform, and it leaves the scar from where it falls, like pretty much every other type of landslide. So I kind of lied on the first slide. There is one YouTube video where part of it's about Earthflow, but I didn't really like it that much because it was kind of broad. So like it says, like water saturates the soil. Well, okay, well how does it saturate? Well, in big rainstorms. So it was kind of broad, and then also it just had the description of it being rapid. Well, how rapid? You think of a debris flow, you think, oh, that's going 35 miles per hour. So it's not as fast as a debris flow. So there's nuances to it, but it's still not like it's not a creep, but it's not as fast as a debris flow. It's like right in the middle. So the Bride model also is just it doesn't really show it well. Like if you have a model, you kind of want to exaggerate it, and his model doesn't do a great job of that. So it's kind of looking at norms notes and some of the USGS data, and then also the GSA data, like statements. I found them to be a little more helpful. So just kind of getting more sources to prove your point. And also, I included the better model on the bottom left, and you can kind of see the exaggeration and why I think it's better. And one more point on the pace of an earth flow is that it can be really rapid, like almost like a debris flow, but it can also be really slow, like almost slow as like maybe a slump occurs. So it's a lot of variability. It doesn't have one determined speed like a debris flow would. Then on this last slide, I just have some visualizations of what it looks like kind of out in nature. So in all of these, you can kind of see the scar at the top. That's one thing that's really visible. And then the one on the bottom left, you can kind of see how the flow is reworked and kind of to make it a homogenized material of different soil horizons. There's a video right here, but the platform I'm recording on, you can't click on the video. So I'll also put it in my response that I turned in. But it's just a quick 6-second animation. That's just a good visual of how the most often earth flows happen, with rain falling down and the material being dislodged in some way and going down the slope.